Okay, let's give you guys some more practice. So now we are on Mercury. The scarecrow is 400 meters away. Gravity on Mercury is 3.7 meters per second squared, and we're going to fire the cannonball at 45 meters per second at an angle of 62 degrees. So this time all we're able to hit the scarecrow. So to answer the question, find out the range. Find out the range of this cannonball. Okay. So press pause and have a go. Okay. So again, we because we're shooting something diagonally, let's break it up into its horizontal and vertical components. So here the vertical component would be 45 sine 62, and the horizontal will be 45 cos 62. Okay, and then jump to your velocity time graph. Your velocity time graph will look something like this. Velocity time. This thing here will be um, uh, this thing here would be 45 sine 62, and then the equation for this line here will be v equals 45 sine 62, take away gravity. I made a mistake here, sorry. Gravity on Mercury is 3.7, so 3.7 t here. So yeah, so find out the normally find out the time it takes to get to maximum height here, because this bit here is quite crucial. It will then tell us the total flight time. So if we can find out the time it takes to get to the maximum height, then times it by 2 to get the whole flight time. Okay, hang on, sorry. Yeah, so find out this point here. This point is quite crucial. So at that point, the velocity would be 0. So put 0 into this v here. So 0 equals 45 sine 62 minus 30, well, 3.7 t. Now add this to both sides. So that would be 3.7 t equals 45 sine 62, and then so t equals 45 sine 62 over 3.7. So this so the time it takes to get to maximum height, this point here, is given by this. Okay. Now that we want to find out the total flight time, so this point here represents the total flight time. So we're just going to get this times by 2. So we'll get this times by 2. So flight equals this times 2. So basically times 2. This gets multiplied to the top. So 45 times 2 would be 90 sine 62 over 3.7. So this is our total flight time. Remember, at the moment, this times this, and this sine 62 is just a number. So when you times 2, just merge the 2 with the 45. So it becomes this. Okay. So that's the total flight time. Now that we've got the total flight time, imagine you and your dad sitting in a car now, traveling at this speed here, 45 cos 62. So now, the total, you would then get the total flight time and then times it by the speed of the car. Okay, so that would tell you the range of this cannonball. So range equals, hang on, range equals this thing here, which is 90 sine 62 over 3.7 times the speed of the car. So that was 90 cos 60. Was it 90 cos 6? No, it's 45 cos 6. Sorry, 45 45 cos. 45 cos 62. Okay, so now well, this is multiplying a fraction, so multiply it to the top. So that will be 90 times 45. Hang on, clear, 90 times 45 equals this. 40, 50, sine 62, cos 62 over 3.7. Okay, so now you've got this times this times this. Okay, so just jump to your calculator and do it. I hate my calculator, so I'm going to do it one step at a time. So cos 62, cos, where's cos? Cos is here, so that will be 0.47. So this thing here will be 0.47. Okay, and then this sine 62 here. Hang on. Yeah. So sine 62. Sine 62 would be this. So this would be 0.88. Okay, and then you've got to times it by this, and then later divided by 3.7. So that equals well, yeah. So hang on, let me just do this here. So it's basically this times, where is it? Times 0.47, and then times that big number, 4,050 equals that, and then divided by gravity, divided by 3.7 equals this. Oh, nearly. So here it's roughly 454 meters. So the range of this thing here is 4. Well, what's happening here is that the cannonball landed 450, was it 454 meters away. So hang on, let me clear this. So the cannonball has landed 450, was it 50 or 50? Well, anyway, 450 something meters away. So we nearly managed to hit our target, but not quite. Okay.